This video explains the concept of expansion boxes and how to use them to multiply polynomials. Expansion boxes are just another way of looking at the distributive property. Now I'd like to begin with a review of numeric multiplication. So we're going to multiply 23 by 31. Now the first thing you might do if you were doing this is to multiply 1 times 3, and you would get 3. Next, you would multiply 1 times, well, you might think it's 1 times 2, but it's really 1 times 20, and you'd get 20. Then you would multiply 30 times 3 and get 90. And then you'd multiply 30 times 20. It's not really 3 by 2, it's 30 by 20. And you'd get 600. And then add all of those up to get 713. And that's 23 times 31. Now, multiplying numbers can be modeled using a rectangle and finding the area of a rectangle. So let's use an area model, as you see here, to multiply 23 times 31. Now we can break the model up into, or the rectangle rather, into 4 sections. Along the left-hand side, the two segments, one of length 20 and one of length 3, combine to give you the height of 23. And along the top, that segment combines a segment of length 30 and a segment of length 1 to make 31. So now we have a rectangle that is 23 by 31. What we're going to do is we're going to find the area of each of the little rectangles that you see and then add them together. So, starting in the lower right, that space is 3 times 1, so that has an area of 3. Next, above that, that has dimensions of 1 by 20, so that's 20 times 1 is 20 is the area of that one. Then down below, that rectangle is 3 by 30, so the area is 90. And the area of the last rectangle is 30 by 20, and that has an area of 600. And once again, if we add 3 plus 20 plus 90 plus 600, we get 713, which is exactly what we did before. Now when we multiply binomials, we can set up a model, an area model, like we saw before. We can take a rectangle, and we can make the size of the rectangle, in this case, x plus 2 by x plus 5, divide it the way we did before, and then split the height into a segment of length x and a segment of length 2, and the width into a segment of length x and a segment of length 5. Now we can find the area of the entire rectangle by multiplying to find the area of each of the smaller rectangles. So x times x is x squared, x times 5 is 5x, 2 times x is 2x, and 5 times 2 is 10. Now the area then is the sum of all of those, x squared plus 5x plus 2x plus 10, which is the same thing as x squared plus 7x plus 10. So what we've done is we've multiplied the binomials x plus 5 times x plus 2, and we've gotten the result of x squared plus 7x plus 10. Now let's take a look at this problem. And here's where we transition from a direct area model into what we're going to call expansion boxes. So let's take a look at how we would model x minus 3 times x plus 2. There's the rectangle. The sides are going to be x minus 3 by x plus 2. We'll draw the sections. The height is x plus 2, but the width is a little problematic from a geometric standpoint. We have a segment of length x and then a segment of length negative 3. Now, we're going to think of this now really as a table rather than a strict geometric model. We'll fill out this multiplication table and then add the areas and still come out with the correct result. So x times x is x squared, x times negative 3 is negative 3x, 2 times x is 2x, and 2 times negative 3 is negative 6. If we add everything up, we get x squared minus 3x plus 2x minus 6. Minus 3x plus 2x is equal to negative x, so this simplifies to x squared minus x minus 6. Now the next example shows why I'm using expansion boxes, and I'm not really mentioning FOIL for those who know what it is. In an example like this, FOIL fails, but expansion boxes work really well. Now let's see how to set this one up. So we'll make our rectangle. The sides will be x squared plus 3x plus 2 by x squared minus x minus 1. And now we'll divide each of the sides into 3 pieces. So we have this 3 by 3 table. Down along the left-hand side, we'll label this x squared minus x minus 1. And across the top, x squared plus 3x and plus 2. We fill out the first line by multiplying x squared times x squared, we get x to the 4th. X squared by 3x is 3x cubed, and x squared times 2 is 2x squared. On the second line, we will multiply negative x times x squared. That will give you negative x cubed. Negative x times 3x is negative 3x squared, and negative x times 2 is negative 2x. And then on the bottom line, we'll multiply by negative 1, and there's the result. And if we add all of the terms inside, this is what you get. Now let's see where those terms came from. X to the 4th was over there. The two x to the 3rd terms happen to be on diagonals. You can see them there. The x squared terms were along the main diagonal. The x terms were along the smaller diagonal, and then the constant term is left. When we combine like terms, this is the result. This method of multiplying polynomials is called expansion boxes, and what you see in front of you is a 3 by 3 expansion box. Earlier in this video I mentioned FOIL, and I wanted to tell you a little bit about what it is and why I don't use it. FOIL is an acronym for first, outer, inner, and last, and describes the sequence of multiplications that you have to do to multiply these two binomials. You multiply the first terms in each binomial. 5x times 2x gives you 10x squared. Next, you multiply the outer terms, 2x times negative 1, giving you negative 2x. Next, you multiply the inner two terms, 3 times 5x, giving you 15x. And then you multiply the last terms in each. That's 3 times negative 1 is negative 3. And then add the results together, and you get 10x squared plus 13x minus 3. Now, here's why I don't like it. First of all, it only works for multiplying two binomials. Otherwise, FOIL fails. So if you look to the right, x squared plus 3x plus 2 times x plus 7 can't be multiplied using FOIL. You actually have to either use expansion boxes or you have to use the distributive property directly. The second one is not two binomials, so FOIL fails as well. And for the third one, there is no way to directly multiply all three of those. What you have to do is multiply the first two together to get x squared plus 3x plus 2, and then multiply that result by the third one. And there again, you can't use FOIL for that, since one of the multiplicands is going to be a trinomial. Secondly, FOIL is not a verb. You don't FOIL two things. And FOIL is not a math term. When we use the word FOIL, we hide the fact that we're multiplying, and we hide the fact that what we're really doing is using the distributive property. There is a tendency to use the word FOIL as a verb, say, I'm going to FOIL these two things, but then you kind of forget that what you're really doing is multiplying. And what I want to do is I want to have students remember that they're multiplying and be able to multiply things other than binomials.